Hello. I am Jaron Lanier, and I'm so happy to be in Korea. I love Korea. I wish I spoke Korean, and it's frustrating to me that I don't, but even so, I will tell you a story that I hope will translate well and that you will enjoy. The story is about the invention of avatars and about what the future of avatars might be. Now, I noticed that we saw a little bit from the movie Avatar, and that was an interesting movie, but in my opinion, real avatar technology, which we can create at this time in a laboratory, is actually even more interesting and even more amazing than what we've seen in the fictional portrayal of avatars in movies like Avatar. Now, as it happens, I invented avatars. This is a very strange thing, but it just happens to be true. It happened in the 1980s, almost 30 years ago, which makes me feel very old, but these are the surprises of life. I never realized at the time what a big deal this very interesting little experiment would turn into. So the experiment took place in a garage in Palo Alto, California. This is where traditionally technology innovations happen in California, in a garage. And it happened that I was very lucky. I had made some money from a very successful video game at that time, obviously a very early one. And instead of using the money the way a normal person would, like getting a house or something, we said, we need to invent something. And my friends and I took the money and we started to develop this entirely new type of machine that hadn't existed before. And it was called a virtual reality machine. That's what I decided to call it. And the idea with virtual reality, of course, is that you have some way of seeing three-dimensional images that surround you, and we were using goggles or special glasses on your head. But that had already existed. That was actually invented a very long time ago. Not many people realize this, but the first head-mounted display actually was created in 1969 by Ivan Sutherland, who also invented computer graphics. But what we did that was new was we connected people using these together in a network. And that meant that more than one person is in the virtual world at one time, and that means if you look at somebody else, you actually see what they look like, and they have to look like something. And so that's why we had to invent avatars. Now, in the early days, avatar technology was, it was painful. It was painful because in order to become an avatar, you have to put on a special bodysuit. And these bodysuits are still used today for motion capture for animation. But in those days, the very first bodysuits were very awkward, and they would have sensors that would dig into your skin, and you would actually have bruises, and sometimes even bleed. It was a difficult early period in the technology. And then what would happen is we would measure all this information about the body and how it was moving, and we would turn you into an avatar. Now, of course, the early avatars were very crude compared to what we see in modern computer graphics. But there were aspects of that experience that were incredible, profound, and that most people still don't know about. So even though the technology has become much more advanced and much more refined as computers have gotten faster and cheaper, there's still a part of that early experience that most people don't know about. And that's what I want to tell you about, because I think it's the most interesting thing about avatars. So the first time I became aware of this dimension of the avatar experience that I want to tell you about, it was because of a bug, because of a software mistake. So the mistake was a very simple one. My hand on my avatar became gigantic. It became like a mile big. So there was this giant hand. And so you're waving around and you see this huge hand. And you think, oh, that's a terrible bug. That won't be any good. If you bend your finger, suddenly this enormous finger comes up at you and then you're inside your own finger and that kind of thing. It's a very strange experience. But what I discovered was that as I created strange alternate avatars like giant hands or very long arms or all kinds of weird arrangements, I was able to still use the avatar body. And this is a little surprising, because usually if you do anything to upset the sensory motor loop or the way your nervous system understands what your body is doing, you become disoriented. For instance, in a virtual reality environment, when you turn your head, of course, the virtual world has to turn the other way to create the illusion that it's standing still, right? But if it doesn't compensate for your head motion rapidly enough, you can become nauseous, you can become disoriented, you can become dizzy. And so this is a very well-known effect. It's one of the things that we had to worry about the most in the early days of virtual reality research. And yet, here, I was making these weird avatars with different body shapes, and it was working. Instead of getting nauseous, I was still able to function. This was entirely a surprise and a very strange one. So the next step, of course, is scientific curiosity led us to ask the question, well, how strange can an avatar become? So we started making really weird avatars. One of the early ones was a lobster. So a woman in my old lab named Ann Lasko made a lobster. She actually got a live lobster in order to model it. And so you could go into virtual reality and be a lobster. And you could use your claws and you had the tail and everything. So now the question is, how do you map the motion of your physical body into the motion of a lobster body? The interesting problem is that the lobster has extra legs. There are these 3 little legs on each side that a person doesn't have. So what do you measure on your body to control the extra legs on a lobster avatar? What do you do? Okay, so we tried many different things. But a very simple thing we tried was to create what we call a virtual parameter, where you take a little bit of maybe a knuckle, a little bit of an elbow, a little bit of your waist, a little bit of an ankle, and apply all of them to, say, the middle joint of the second arm on the right. And you do this of just grabbing a little bit of information from different parts of the body so that you can still move overall, but if you're careful, you can be aware of how you're influencing the extra limbs as well. And the amazing thing is that it's a complete surprise, but it turns out people can do that. People can control a lobster avatar, and pretty naturally, especially children. This was a total shock. And the experience of controlling an alternate body is a really profound, really fun, really deep, really unexpected sensation. It's something that is going to be a tremendous delight, I think, for many people, even though very, very, very few people have experienced it so far. Now, one of the scientific questions is, why should this even be possible? I mean, it doesn't make sense. It's not what you would expect. So the answer to that question was provided by a biologist named Jim Bauer. And he pointed out something very interesting, which is that the human brain is actually part of a very long line of evolution, and that from the brain's point of view, human beings are a fairly recent body format. The same brain, more or less, has had to evolve through coordinating the bodies of all kinds of different animals. The ancestors of people swam, crawled, all kinds of things. And so the brain is what evolutionary biologists call pre-adaptive for a range of body types. You can think of this ability that the brain has to control different avatars. You can think of that ability as almost like a time travel machine for the brain. For instance, if you become a fish in virtual reality, and I have to admit, I have never become a fish in virtual reality, although perhaps I will try it. But if you were to become a fish, from your brain's point of view, it's like you've gone into a time travel machine backwards in time to when parts of the brain were actually controlling a fish body. And furthermore, designs in biology are always pre-adaptive for future evolution. This is a slightly difficult concept, but the idea is that everything in biology has functions that are waiting to be discovered as creatures exist in the environment, and it might turn out that some of those features are useful in ways that had never been discovered before. So, in a sense, the human brain is pre-adapted for all kinds of future changes, all kinds of future creatures, all kinds of future experiences that we can't imagine, because every part of the human body and every part of every design in nature is pre-adapted for all these things that can't be imagined. Now, the part of the brain that maps to the body is called the homunculus. Okay? It's a strange word. And it exists along the top of the brain, along the center. It's a part of the cortex. It's called the motor cortex because it controls motor activity. When people draw pictures of the homunculus, they often draw a strange-looking creature that could almost be like a fantasy avatar. And the reason why is that the human body doesn't map directly to the brain. Instead, parts of the body that have more nerve connections are bigger in the brain. So the homunculus looks like a very strange creature with a giant thumb and a big tongue. It's almost an obscene creature, a very weird avatar. One of the art projects that somebody has to do, and I'd like to challenge this audience, somebody here should be the first person to make an avatar that actually is a homunculus. So the brain can just experience finally a direct mapping to a body as it in the most natural form, because the brain has never experienced that. Now, I've described to you a little bit about the science of avatars and a little bit about the discovery of avatars and the discovery of this phenomenon we call homuncular flexibility, which means that the brain can control all kinds of creatures other than humans. So that's a little bit about the science. There's much, much more to learn about the science. One of the things we're working on now is trying to understand what kinds of avatars you can turn into and what you can't turn into. So at Stanford, we have a project, at Stanford University in California, we have a project where we're putting student volunteers through a laboratory where they're turning into all kinds of weird avatars so we can map out the extent of homuncular flexibility. Just how weird can avatars get? No one knows. So we'll discover that. Now, in addition to the scientific questions, which are really interesting to me, there's also the practical question. Is this good for anything? Is there any benefit to doing this? Can you make a technology out of this that'll be useful for anybody? And I think the answer is yes. I think we can do something really, really amazing. And in order to explain that, I'll start with the story of my first application experiments with avatars. And I decided to work with children because children can adapt to strange avatars so quickly. Adults adopt quickly too, but children, it's almost like instant. So what I thought is, why don't we try using this idea of radically unusual avatars as a form of education? And what I did is I took children in the age of 10 to 12 and I turned them into molecules in a chemistry simulation. So now the avatar is not a blue alien, the avatar is not a lobster. Instead, the avatar is a molecule, like for instance a glucose molecule. And now as you move around, your body is mapped to the degrees of freedom of this molecule. Now normally in chemistry, because everything has heat, everything is thermal, the molecule is kind of jiggling or exploring randomly the different configurations it can take on. And then of course it's interacting with fields from other molecules nearby. So in this case, instead of you just like being thermal, the way a real molecule is, you sort of turn the molecule into a creature and you explore the different degrees of freedom. And then you can start to learn what other kinds of molecules glucose can interact with. Now, I tried many other experiments. I had the kids turn into triangles to learn trigonometry. I had them turn into DNA. But what I want to say is that this really works, and it's a really great experience. Now, the metaphor that I found very helpful in understanding what was going on comes from learning to play the piano. I play the piano, and I enjoy improvising on the piano. Now, there's a very interesting moment that happens as you're learning to improvise on the piano, where suddenly, one day, you notice that your hands seem to have solved difficult problems in math and logic faster than your brain can keep up. Now, the way this happens is as you're improvising, you have different melody lines that some of your fingers are creating, and there's a chord motion, there's harmony, and there has to be voice leading. And sometimes, to figure out how to get all of that to work together is actually pretty tricky. That's why composing music can actually be hard work sometimes. So you're improvising and suddenly you notice, wow, my hands just solved this problem in harmony and voice leading, and I don't even quite know what I did, but it worked. And then you can, if you recorded it, you can figure it out later, and you can say, wow, my hands are smarter than my brain. Now, of course, that's not true, because it's all your brain, but the interesting thing is it's different parts of your brain. We're used to certain parts of the brain doing all of the hard work in terms of logic and reasoning. We're used to the parts of the brain that are associated with language and symbolic reasoning to do that. And I'm pointing to the side of my head because this is where those parts are. But this example of the piano, and there are many other examples I could use from surgery, from certain kinds of sports, where these demonstrate that the part of the brain that runs the body, the homunculus, which I described, which runs along the top of the head, is also capable of incorporating logic and reasoning and problem solving. So when you learn to improvise on the piano, it's not that your hands are smarter than your brain, it's that you're waking up a part of your brain that's smart that you usually don't wake up. It's a part of your brain that's pre-adaptive for something. Going back to the story of evolution I was just telling you. So when you become a molecule, you're learning chemistry in a new way. You're learning chemistry with this part of your brain, the motor cortex, and you can start to develop what we sometimes call intuition, which I think is really just another kind of cognition. You're starting to just open up, wake up different parts of your brain that you normally don't use. Now, it has to be pointed out that there's something else going on here too, which is purely psychological. All people, and especially children, are naturally interested in themselves. So if you turn into the molecule, then learning about chemistry is just another way of paying attention to yourself. Do you see? So what we can call narcissism or self-interest all of a sudden becomes something that's drawing people into education. So that's the emotional side of it. Now, there's a very natural question to ask here, which is, how far can this go? I don't know. This is an open frontier. This is the edge of science. This is where we're facing a mystery. But that frontier is about to open up. And the reason why is that the instrumentation, the hardware, has just gotten a lot better. And that happened this week. I've been waiting to be able to say this for 30 years. This is a very big deal. Prior to this week, if you wanted to turn somebody into a whole body alternate avatar, you had to put them in a suit and you had to calibrate the suit. And that process could take 20 minutes, 30 minutes, even an hour. And it just was impractical, especially with children. What just changed is my laboratory, where I'm working now at Microsoft Research, has completed a little camera called Kinect. That's a 3D camera with software that was quite difficult to develop that derives your whole body pose automatically in real time. So now all I have to do is point one of these special cameras at you and I can get the full body pose. So all of a sudden, now, this week, this type of research has become easy. It's amazing to me. So we're just about to embark on a new frontier of exploring how far it can go. I can tell you the things I want to try. In addition to things like molecules and scientific models, engineering models, I want to explore abstract models. I want to turn people into equations. I want to turn them into programming expressions, into database structures. I want to see if people can use this to understand a level of complexity in the computer that's been difficult to understand. I was present around 30 years ago when I started this work with the visual revolution. The visual revolution in computers was amazing because the ability to just see things on a screen with a graphic user interface made computers usable by ordinary people instead of just engineers. What I'm hoping is that this type of full body experience, using the intelligence of this part of the brain, waking it up, waking up that potential, is going to do something like that for the internet, for new levels of complexity. I think I can enable, I think we can enable a new kind of cognitive literacy, a new kind of cognitive ability in large numbers of people. I have just officially run out of time, so I can only share with you another sentence or two. And what I want to tell you is that there are two ways to think about technology. One way of thinking about technology is that the technology itself, the computers, whatever they are getting better and better. And that's true. That's a valid way of thinking. But there's another way of thinking about technology that's equally valid, and I think might even be more important. And that is that whenever we make better technology, what we're really doing is we're waking up new potential inside ourselves. We're waking up new potential experiences, new kinds of intelligence. And to me, that's the more profound path. That's the most important thing. And it's my pleasure to be able to tell you about this one little adventure in waking up new type of human potential. So thank you so much for having me here.